Hi everybody, welcome back. So this is our continuation of our topic of using distances and speeds on Earth's surface and other information about the Earth's surface to calculate various information. So just a reminder from what was covered last lesson, we learnt about latitude and longitude, and latitude tells us how far a country or a place is north or south of the equator. Remember, lats go flat, lats go around the Earth's surface, and you can see that here. They're going around this way. They're going horizontally around the world. And if you, the main point of latitude or reference point of latitude is the equator, which is 0 degrees, and everything starts from there. And remember, the equator is in the middle. Lats go flat, one way to remember it. Longitude, or if you think of it going long ways, goes vertically, and they go through the poles. They go through the North Pole, the South Pole, the Arctic, the Antarctic, and they tell us how far a country or a place is east or west of the prime meridian. Remember, we talked about the prime meridian last lesson, and that is where it is 0 degrees longitude. It's also really valuable to remember that meridians are also called great circles, because you might get asked a question about that, but meridians are all the same size and they're all also called great circles. Notice that the parallels of latitude are not necessarily the same size because they're getting smaller as they go closer towards each of the poles. Now, when we write information about latitude and longitude, it's always latitude and direction, longitude and direction, always in that order. So here's an example. So a place that has a position of latitude 35 degrees north, longitude 26 degrees east is written as 35 degrees N, 26 degrees E. So note there's no comma between those, so don't put that. But you need the number of degrees and the direction, and always latitude first. So that's why you don't need to say what it is. So based on that, let's continue with today's topic, because we're going to use that information about the latitude and longitude to find out some more information. So what we're going to do today is to calculate how far, or the distance between two cities, two places. And to do that, we need to factor in what's called the curvature of the Earth. Now, the Earth is obviously round, not flat. So that curve in the Earth's surface has to be taken into account. And we do this by using a couple of formulas. And what this does is multiply the amount of the difference in the longitude by that formula, and it takes into account that curve. So here are the two formulas. So if there's a difference in latitude, so in other words, there are two different places in latitude in the Earth's surface but the same longitude, you're going to multiply every degree of distance by 111.2 kilometers. And of course, we'll do examples in a minute. If there's a difference in longitude, or east-west, we're going to use, for every 1 degree, we'll multiply that by 111.2 cos theta kilometers. And remember, theta is just a variable. In this case, theta represents whatever the latitude is of that position. When we know how far apart two places are, we can easily figure out how long it's going to take us to get there. And we could also figure out how fast we need to go to get there in a certain time frame that we might want to do. So this type of stuff is really important because ships and airlines use that all the time to figure out how far it is to somewhere, how long it's going to take. That's how they decide how long flights are going to take, and that's how they tell you how long they're going to take. And also, importantly, that there's enough fuel on board to get there. If you don't know how far something is and you don't have enough fuel and you're flying, you could have a big problem. So this sort of stuff is super important, and that's what they use. So let's have a look at an example. So find the distance between Auckland Island, 51 degrees south, 166 degrees east, and Noumea, which is at 22 degrees south, 166 degrees east. We also need to find the time it would take to travel in a boat averaging 15 kilometers an hour. Now, the first thing to notice about those two distance, or the two place longitude and latitude measurements is our longitude is the same. You can see that here, 166 degrees east, 166 degrees east. So what that means, they are on the same meridian. If there's no difference in longitude, they're on the same meridian or same great circle. So because that's the case, we only need to find the difference in latitude to find the distance and use the information we were given, those little formulas. So step number 1, calculate that difference in latitude. And it's literally whatever the latitude amount is taken away from the other one. So 51 degrees minus 22 degrees. So that's 29. 29 degrees is the difference in the latitudes. Now, something I want you to stop and think about for a minute is what if one was north and one was south? So you can see in this case, both of our latitudes are south. They're both south of the equator. But if one was north and one was south, we need to do something a little bit different. So let's say this is our position here and we're 59 degrees north of the equator, and we want to go to a place that is 67 degrees south of the equator. So keeping in mind that the equator is 0 degrees latitude there, instead of deducting them from each other, we need to add the two latitudes together. From 59 degrees down to the equator, that's 59 here, because it's 59 minus 0 at that point. 59 minus 0. From this 67 degrees south up to the equator is another 67 degrees, because that's 67 minus 0. So to get the full distance between them, the difference, we have to add those two together. So that's the one trick to remember about this. If one is north and one is south, add them together to get the difference. Don't subtract. So you first of all need to determine, are they both in the same hemisphere, north or south? Any problems with that? Let me know. So once we've got the difference in our latitude, we can use that little formula I gave you before to calculate it. So it's the distance between them is that 111.2 times the difference in latitude, because they're exactly the same longitude, so we don't need to worry about that. So using that, 3225 is the kilometers, is the distance between those two places. Just multiplying it out. To calculate how long it's going to take to get there, we need to use the speed formula. Now, remember we talked about that back in term 2, so this stuff you learn you're supposed to retain. So hopefully you remember that. Speed equals distance over time. Of course, you can rearrange that lots of different ways, but my recommendation is to you guys, for those who struggle with that, is just to use speed equals distance over time, substitute the values you have in, and then rearrange, because it's often easier to rearrange with numbers and get it right. So we were told in our question 15 kilometers an hour, and we just figured out that it's 3,225 kilometers. So how long will it take? So I've substituted in and I've rearranged. So you have to do the bottom of the fraction first. Don't get confused about that. So time times 15 kilometers an hour equals 3225. Time equals 3225 kilometers divided by kilometers per hour. Now, note that the kilometers will cancel here, so you're just going to be left with hours as your units. So that's 215 hours is how long it's going to take to get there. Okay, I'm going to leave it there and we'll do another example shortly.